The hexadecimal you provided corresponds to a 6502 assembly language routine stored in the binary file SR on your Apple II 5.25 inches disk. This file, listed as a B binary file with a size of 2 sectors 512 bytes, contains machine code, and the snippet you shared is a small program or subroutine located at memory addresses $322 to $33 Below, I'll analyze the code to explain what it does, focusing on its functionality in the context of an Apple II game from 1982. Code analysis. The assembly code is written for the 6502 microprocessor, which powers the Apple II. Let's break down each instruction. 0/322, AD30C 0 $C030. Load the speaker port toggle speaker 0/325, AD20 03 $320. Load value from memory address $320 0/328, 28 FCJSR $CA8. Call wait subroutine Apple II ROM. 0/32B, AD21 03 $321. Load value from memory address $321 0/32E, D005 net $335. Branch to $335. If value is not 0/330, set 3C03 dec $33 C. Decrement. Value at memory address $33 C 0/333, F006 dec $33 B. Branch to $33 B. Return. If value is 0/335, set 2103 dec $321. Decrement value at memory address $321 0/338, 4C22. 03 JNP $322. Jump back to $322. Loop 0/33B, 60 RTS. Return from subroutine. Step-by-step explanation 1. Purpose. This routine appears to be a sound generation subroutine, likely used to produce a simple tone or beep on the Apple II's built-in speaker. It uses timing loops to control the frequency and duration of the sound. 2. Detailed breakdown. C030 at $322. The Apple II's speaker is controlled by accessing memory address $C030. Reading or writing to this address toggles the speaker state, causing it to click. Rapid toggling creates a waveform, producing a tone. This instruction toggles the speaker to generate part of the sound wave. $320 at $325. Loads a value from memory address $320 into the accumulator. This address is in 0-page low memory $0 $0 FF or low RAM $300 3 FF is often used for temporary variables in Apple II programs. This value likely controls the frequency or delay of the sound, how fast the speaker toggles. It's used as a parameter for the wait routine. JSR $CA8 at $328 calls the Apple II ROM's wait subroutine at $CA8. This routine pauses execution for a duration proportional to the value in the accumulator loaded from $320. The wait routine is commonly used in Apple II programs to create precise delays, critical for controlling the pitch of a sound. Higher values, longer delays, lower pitch. $321 at $32 B. Loads a value from $321, likely a counter for the number of sound cycles or loops to generate the tone's duration. Net $335 at $32 E. If the value in $321 is not zero, branch to $335. This creates a loop to extend the duration of the sound. Dec $33 C at $330. If $321 is zero, decrement the value at $33 C. This address likely holds another counter, possibly for the total duration of the sound or the number of times the routine should repeat. Dec $33 B at $333. If the value at $33 C is zero, branch to $33 B, which contains the RTS instruction to exit the subroutine. This ends the sound generation. Dec $321 at $335. Decrement the value at $321, reducing the cycle counter for the inner loop. JNP $322 at $338. Jump back to $322 to repeat the process. Toggle speaker. Wait. Check counters. RTS at $33. B. Return from the subroutine, ending the sound generation when the counters reach 0. 3. Overall functionality. This is a sound generation loop that produces a tone by toggling the Apple second speaker $C030 at a frequency determined by the value at $320 via the wait routine. The duration of the tone is controlled by two counters. $321 controls the number of speaker toggles per cycle inner loop. $33 C controls the total number of cycles outer loop. The routine loops to create a continuous tone until the counters reach 0, then exits. 4. Context in the game. Given the file name SR, possibly short for sound routine or subroutine, this is likely a utility function called by the main game E.G, wilderness or dungeon to play sound effects or music. In 1982 Apple's second games, sound was rudimentary, often limited to beeps or tones. This routine could generate a sound effect E.G, a beep for a menu selection, a hit in combat, or a dragon's roar. A simple musical note or sequence for a game event. The use of Dragon 0 and Dragon 1 files suggests this could be part of a dragon-themed game, where SR plays a sound for dragon actions E.G, fire breath, movement. Technical details, memory usage. The code resides in the $322 $33B range 25 bytes, which is in low RAM, a commonplace for small subroutines in Apple second programs. Variables at $320, $321, and $33 C are likely initialized by the calling program E.G, the basic program wilderness or dungeon using poke commands to set the pitch and duration. Sound generation. The Apple second speaker produces sound by toggling $C030, creating a square wave. The pitch depends on the delay between toggles set by $320 and the wait routine, and the duration depends on the counters $321, $33 C. Typical frequencies for Apple second games range from 100 Hz to 2 kHz, limited by the 1 MHz 6502 CPU. File size. The SR file is 2 sectors 512 bytes, but this routine is only 25 bytes. The rest of the file might contain additional code, data, or padding. You could inspect the full file with a hex editor E.G via CyderPress or your emulator's debugger to see if there are other routines. How it fits in the game. Role in game. This routine is likely called from an Applesoft basic program E.G. Call 818 in basic, since $322 818 in decimal to play a specific sound effect or note. For example, the wilderness or dungeon program might use poke 800, pitch, poke 801, duration 1, poke 828, duration 2, call 818 to set up and play a sound. Game context. Given the file names wilderness, dungeon, dragon 0, dragon 1, this could be part of a fantasy RPG or adventure game. The SR routine might play sounds for events like entering a dungeon, encountering a dragon, or casting a spell. Modifying or experimenting. If you want to modify this routine or experiment with it. 1. Change pitch. The value at $320 controls the delay pitch. Use a basic program to poke a different value. Poke 800, 100 call 818. Smaller values E.G, 50 produce higher pitched sounds. Larger values E.G, 200 produce lower pitched sounds. 2. Change duration. Modify $321 or $33 C to adjust the sound's duration. Poke 801, 255. RAM inner loop counter poke 828, 10. RAM outer loop counter call 818. 3. Debug in emulator. Use your emulator's debugger E.G. Apple Wins F7 key to step through the code at $322. Set breakpoints to watch how $320, $321, and $33 C change. Check the full contents of the SR file to see if there's more code E.G. Load it with load SR and inspect memory. 4. Replace the routine. If you want a different sound, you could write a new 6502 assembly routine and save it to the disk using a tool like Merlin, an Apple second assembler, or a modern cross assembler. For example, change the delay or add multiple tones. Limitations and notes. Limited information, without seeing the full SR file or how it's called E.G. From wilderness or dungeon, I can't confirm its exact role. E.G. Specific sound effect. If you run the game or share more context. E.G. What happens when you run hello? I can refine the analysis. Emulator tools. Use tools like CiderPress to extract the SR file from the disk image and view its full contents. This could reveal additional routines or data. Game identification. If you provide the full catalog or describe the game's behavior, I can try to identify it or find documentation. E.G. via web searches or Apple II archives. Conclusion: the SR binary file is a 6502 assembly subroutine that generates a tone or sound effect on the Apple II speaker by toggling $C030 with timing controlled by $320 pitch and $321.33 duration. It's likely used by the game's basic programs Wilderness, Dungeon, or Hello to play sound effects or simple music, fitting the 1982 Apple II game context, possibly a fantasy, RPG, or adventure. To explore further, try running the game, poking different values into $320, $33, or sharing more details about the disk or game behavior. Let me know what you want to do next.